welcome again in our laboratory. From the previous video, we talked about electrochemistry, but now we will move on to potentiometry. Before anything else, this is our learning objectives and our conceptual framework. Now we better start the discussion. In chemical analysis, potentiometry is a method in which the potential between two electrodes is measured while the electric current between the electrodes is controlled. Therefore, it is very useful as a quantitative method. So who discovered potentiometry? Well, it is Fritz Haber in 1901 who discovered that there is a change in potential across a glass membrane when its two sides are in solutions of different acidity. The principle of potentiometry is that when the pair of electrodes are placed in the sample solution, it shows the potential difference by the addition of the titrant or by the change in the concentration of the ions. Potentiometry-based analysis methods are highly important in the field of electrochemistry. It is commonly used for the determination of different organic and inorganic ions in various areas such as process control and environmental, industrial, agricultural analysis, and also medicinal drug analysis. There are two types of potentiometry, namely the direct and indirect potentiometry. The direct potentiometry utilized by blood gas machines and does not include sample dilution, while the indirect potentiometry utilized by automated chemistry analyzers. In potentiometry, there are two electrodes that are used, which are called the indicator electrode and the reference electrode. The indicator electrode possesses some characteristics that allows it to selectively respond to changes in the activity of the analyte being measured, while the reference electrode is an electrode which has a stable and well-known electrode potential. This allows the potential of the other half cell to be determined.
Good day everyone, my name is Michael Martinez, and today we will going to tackle about potentiometric titration. What is the principle of potentiometric titration, its method, and types of potentiometric titration. Now, let's start. Potentiometric titration is a titration used to measure the amount of analyte present in the given solution by measuring the change in the potential by a suitable indicator electrode as function of volume of titrant. It is the procedure through which the quantity of the given test substance is determined by the measured addition of titrant until the entire test of substance undergoes reaction. Potentiometric titration principle. Potentiometric titration is a laboratory method to determine the concentration of a given analyte. It is used in the characterization of acids. In this method, there is no use of chemical indicator. Instead, the electric potential across the substance is measured. Potentiometric titration method. Potentiometric titration method is done via the usage of two electrodes, an indicator electrode and a reference electrode. Generally, a hydrogen electrode or a silver chloride electrode. One half cell is formed with the inductor electrode and the ions of the analyte, which is generally an electrolyte solution. The other half cell is formed by the reference of electrode. The overall cell potential can be calculated using this formula. So we have E cell is equals to E indicator minus E reference plus E solution, where the potential drop between the indicator and reference electrodes over electrolyte solution is given by E solution. So the overall cell potential, E cell, is calculated in every interval where the titrant is measured and added. Now a graph is plotted with the potential difference on the y-axis and the volume on the x-axis. So let's look at this graph. It can be observed from the graph that the electric potential of the cell is dependent on the concentration of ions which are in the contact with indicator electrode. Therefore, the E cell is measured with each addition of the titrant. Now, let's go on to the types of potentiometric titration. So there are 4 types of titration that fall under the category of potentiometric titration. Namely, we have acid-base titration, redox titration, complexometric titration, and precipitation titration. So first we have acid-base titration. This type of potentiometric titration is used to determine the concentration of a given acid base by neutralizing its exact using a standard solution of base acid whose concentration is known. Second is we have redox titration. This type of potentiometric titration involves an analyte and a titrant that undergo a redox reaction. An example of this type of titration would be the treatment of an iodine solution with a reducing agent which produces iodine ion, and a starch indicator is used to get the endpoint. Now, let's go on to the third type of titration. So we have this complexometric titration. This type of titration can also be referred to as scaleotometry. In this method, a colored complex form indicating the endpoint of the titration. This method is used to determine a mixture of metal ions in a given solution. Fourth one is we have precipitation titration. This type of titration involves a reaction between the given analyte and the titrant, wherein an insoluble precipitate is formed. The endpoint of this titration is noted when the addition of the titrant no longer forms a precipitate. I think that would be all for today. Thank you and God bless.
So let's proceed to our next topic, which is the potentiometric pH measurements. The principle of potentiometric pH measurement is traced or can be traced back in 1909 by chemist Søren Sørensen, which he introduced the so-called hydrogen ions exponent pH plus to describe the concentration of hydrogen ions in a solution. This was the basis of the development of the conventional pH scale. So, potentiometric pH measurement is the measurement of a potential differences using the so-called glass electrodes or non-glass electrodes. In the case of glass electrode, the pH sensitive elements is a glass bulb that is fused to the end of a glass tube. The electrode is filled with a neutral potassium chloride solution, buffered pH 7, and contains a silver chloride wire that forms the electrical connection. The reference system is located in the outer glass tube and also consists of silver chloride wire and the potassium of chloride solution. Let's take a closer look to understand the pH-sensitive glass bulb. So diluted hydrochloric acid, for example, contains large negatively charged chloride ions and small positively charged hydrogen ion. When pH sensor is merged into this acid, the hydrogen ions are able to penetrate the boundary area of the glass membrane. The so-called gel layer or the larger chloride ions remains in the solution. The result is charge separation. So if the hydrogen ion concentration, hence the pH value on the inside, differs from the concentration of the outside of a measurable potential difference forms. If the hydrogen ion concentration on the inside is lower than the outside as shown, the measured solution is acidic. If the pH value is lower than 7, if the hydrogen ion is identical on both sides. pH measurement with non-glass sensor is based on the so-called the pH measurement with non-glass sensors is based in so-called ion selective field effects transistors. They use mass transistors arrangement that contains a pH sensitive layer instead of a metal gate. Positive hydrogen ion is forming at this layer cause the charge to be separated the other side. As a result, the area between source and drain becomes the conductive. The resulting flow of current is in direct proportion to the pH value of the medium.